I can start. My name is Mark Delaney. Hello. I know from looking at the chat that there's some customers on this call and some colleagues from the past. If you don't know me, I'm a freelance consultant for Systems Manager Limited. I've worked with the product formerly known as TWS for about 20 years now, and if I refer to it as TWS through this presentation, I apologize. I'll do my best to refer to it as workload automation. What I wanted to do with this presentation was this originally was intended to be presented at the ASAP University in Cincinnati, Ohio last month, and then I was going to present it at the Tivoli User group, but unfortunately because of the pandemic, that has been postponed till the end of August currently. What I will say is it's a strange time for anyone who's got kids at home. Homeschooling is no joke. We'll work through this presentation. What I was hoping to do with this was I first started looking at IBM Cloud Private and containers sort of the early last year. And once IBM Workload Scheduler was going to be moving to Docker containers, I thought it was probably high time that I do some understanding of that. And since then, the focus has been more moved into OpenShift. I'm going to touch briefly on IBM Cloud Private, and then the rest of it is going to be OpenShift. My intention for it is the questions that I had as a TLS administrator when I started looking at this, there was very little around that sort of spoke to me as a TLS administrator. So what I was hoping to do was put this in language and in demos that if I was fresh, new to this, I'd do my best to pick it up, because there is a lot to Kubernetes. Now, we're not talking just IBM Cloud Private or OpenShift, all of the Kubernetes distributions. There is a lot to pick up. And hopefully what I'll get across with this, with OpenShift, you can get as hands-on with it, with nitty-gritty as you want to understand how Kubernetes works, or you don't have to. You can look at a managed service and ease yourself into it that way. It's whichever way that you want to go. But I thought Kubernetes didn't have a learning curve. It was more of a cliff face because there is a lot to it. But we'll work through it, and hopefully with the demos we'll sort of make sense of what we're going to explain with workload automation running on OpenShift. So a quick overview. I don't want to go, this is just an introduction thing, but with containers and Kubernetes, we've all heard of containers and what a lot of people refer to them as Docker, and Docker was just a brand. Docker's more or less fallen by the wayside with other representations of Docker coming out, but essentially, why do you want to containerize applications? So in this diagram, which is from Kubernetes' own website, in the olden days, which is 10 years ago, a traditional deployment would be a piece of hardware, a server, with an operating system and some applications on there. And as time moved on, now the virtualization has been around for years on mainframe and various other platforms. But the question being was, well, we've got the same hardware, we have an operating system and a hypervisor to allow us to carve up what was a single machine into multiple virtual machines. But each of those virtual machines would have its own operating system and act as if it was its own piece of hardware, its own libraries and applications. So there is efficiencies there over the single instance of it, because now I can run two virtual machines. But the problem being is those virtual machines have operating systems that need patching and rebooting and have their own libraries. So these applications can become problematic in that, well, this operating system may not be the same as this one in regards to patching, or if someone's installed a library, then you start hitting problems with applications on one particular virtual machine. And to keep multiple machines in sync across an enterprise where there's hundreds or thousands of machines to do with operation system patches and libraries, to keep them all entirely in sync is just, it's a pipe dream. So you can possibly hit problems with an application that works well on one machine that doesn't work on another. And where containers come into this is a self-contained runtime that can be moved wherever. So the library, there is no operating system to consider because the container is self-contained. It has everything inside it that needs to run the application that it's designed for. So in our IBM Workload Scheduler, it has all the libraries that it needs and all the drivers that it needs. So wherever the container is positioned, whether it's on-premise on on a machine that you've got on your server, or in OpenShift or in Azure or AWS, that container is going to be identical and will run identically regarding of where it's placed. So you could move this container from on-premise to cloud and back again if you need to, or between cloud providers. So the AWSs and the OpenShift providers in the world, you're not tied into one particular vendor of cloud, because the container is your code, your immutable code that you can move wherever you like. And there is no operating system or libraries to update, because the container is its own single entity. So you can also run multiple more containers per piece of hardware than you would with a virtual machine, because there's no operating system to have that overhead. So the efficiencies of scale is exponential up into the container level now. So what we're going to look at now is where Kubernetes came into things. So you had containers that could run your code, which you can run it on your laptop, you can run it on a machine, but Kubernetes is designed by Google to, well, we have all these hundreds and thousands of containers. Well, how do we manage them correctly? How can we ensure that these containers are up and running, that they're healthy? We can do things like update these containers when new versions come along. You need some of orchestrator, of which Kubernetes is the one that's sort of taken over and shows no sign of stopping. Now, Kubernetes is the learning curve that I was talking about before. There is a lot of elements to it that will take time to understand. I mean, I'm definitely still learning on Kubernetes, and it is evolving rapidly. But what I will say is the container orchestration and the future of containers isn't going away. This is absolutely the future. So when we're looking at virtual machines, they're clearly going to be around for a while, but there is, you know, the train of moving things into containers and orchestrate them in the cloud. I mean, you can clearly see from your own company enterprises, everyone's talking about cloud first. A new application comes along, can it be hosted on the cloud first? So the natural progression is, well, can it be containerized and hosted on the cloud? Because we have all these efficiencies of being able to run more containers per piece of hardware than the old virtual machine. So I'm only going to touch briefly on IBM Cloud Private, because this was my first introduction to running containerized applications, because if TWS or IWS is going to run on Cloud Private, I need to go and understand that. Now, I've put some pointers here for this iteration of Cloud Private. Now, I don't know, the current version is 3.2.1. It is still being patched and updated, but it has an end of support date for it. I don't know if there's going to be a new version of this coming out, which is why I'm going to briefly touch on this. But there are elements of IBM Cloud Private still out in production. So if you look at the IBM Cloud Packs and multi-cloud management and various other cloud packs, there is elements of Cloud Private still part of that solution to allow them to run on OpenShift. So I can't say for sure whether there'll be a new version of this, but as I said at the start, we're going to directly look at OpenShift and where the container orchestration comes from that. So Red Hat OpenShift container platform is what we're going to look at today, with the new IBM Workload Automation 9.5 fix.2. The latest version is 4.4. This only came out, I think, last month or 2 weeks ago. I'm running 4.3 on my demo machines, but to upgrade between the versions, doesn't matter if you're on managed or if you're running on bare metal versions of OpenShift, it's extremely easy to do upgrades and manage the infrastructure of OpenShift. This version is based on Kubernetes 1.18 rather, with Cryo container runtime engine. So when we've talked about Docker before, has sort of fallen by the wayside. Cryo is what OpenShift uses for their container runtime engine. So it doesn't have Docker, it uses Cryo, amongst other things, to host those containers inside your hosts. When if you pick up 9.5 fix.2, it comes with some Helm charts and security policies that you can use to build into your OpenShift container platform. And it's in this 9.5 fix.2, it's managed by an operator. Operator is a Kubernetes term that's been around for a while, but there's a big push within OpenShift to use these, because what it's effectively saying is, when you install an application on your OpenShift hardware, they call it day one. So my infrastructure's there, my application's there. So what happens in day two? Well, my application, not just TWS we're looking at here, other applications, databases, the usual things that you'd run in an environment, they're going to need backing up. they're going to need upgrading, they're going to need any sort of maintenance task that an operator would do. And what the OpenShift is trying to do is to build that knowledge into this operator so you can manage your application from once it's running in production, if you like. And there's lots of different vendors and different types of application that are providing their operators to be hosted in the operator hub, which we'll look at in a little bit. The latest release equates to 9.5 Fixed Pack 2. Just 1 second. We're looking at OpenShift. There's a couple of things I want to look at first of all. When I was at the last Tivoli User Group and we talked about OpenShift and containers, I was on the automation track, and the question was, well, how many companies and how many people in the room have started to look towards putting their applications? So I look after Netcool, Insights, Omnibus, and those kind of things. They've been containerized to run an OpenShift, and there wasn't much response, but I can guarantee in the 6 months since there'll be a lot of companies who'll be pushing down the route of OpenShift and getting their applications running on there. And the same applies for IWA. But when it comes to how you're going to have access to OpenShift, there's two ways you can do it. There's installer provisioned infrastructure and user provision. So if you see those acronyms come up, these IPI and UPI, this is what it's relating to. When you're designing and building an OpenShift network, there's a lot of steps that have to be done regarding to, well, building the network. There's some hard requirements when it comes to load balances. There has to be 2 load balancers in front of the infrastructure to handle the API and the console requests. You need things like DNS, you need the operating system itself installed, and there is a lot of effort involved in standing that up. Now, each of the cloud providers, AWS, IBM themselves, OpenShift, will allow you to have their managed system where you just bring them your images that you want to run, and they will look after the infrastructure and everything else. But there's also ways, and we'll see it in the next slide in a moment, where all of the big cloud providers will allow you to do installer provisioned infrastructure, where all of the hard work with creating the load balancers, the storage, everything to do with that can all be done with, it's 2 commands basically. It's an installer command, and you tell the provider what you're interested in your infrastructure, and it will go out and build it for you. Now, if that's not what you're interested in, if you want to have user provisioned infrastructure, and what this means is you have to build out the network and the load balancers and the hardware, etc. But for an enterprise type solution, which is the people on this call will, the larger customers, maybe they don't want to have their systems running in the cloud, it's just not for security, or they want their own systems, they will have the resources on hand for storage and networks to be able to provision this OpenShift cluster internally on their own systems. You can do it on bare metal, you can do it on VMware, or you can deploy to AWS and places like that. So looking at these list of things that the installer provisioned infrastructure does, it's a lot much easier than doing it yourself, but you can do it yourself, whichever is more comfortable for your company. So I'm going to do a bit more on this OpenShift, and I'm going to get to one techie bit and then some demo stuff. So if you can, what we're looking at now is, this is a graphic that came out a couple of weeks ago, because every big player in the cloud provisioning platform is giving you ways to use OpenShift, either installing it yourself, so the user provisioned infrastructure, or they can manage it OpenShift dedicated, which is Red Hat managed completely, or whether the big providers will allow you to install into their own environments on their software with installer provisions. So an architect type person, if you decide which way you want to go. And one thing it comes to when enterprise customers, you probably already have a relationship with a cloud provider, at least one, maybe 1, 2, or 3, and the decision of where OpenShift is going to be installed generally might not come down to TWS administrators or have any input to it. It's just a case of, well, look, our workloads are now going to be on Azure, or our containers are going to be on Azure. We want you to carry on scheduling our jobs wherever they are in whichever cloud. And if OpenShift is the way you're going to go with TWS, with IWS, you can still deploy and provision and schedule jobs against all of the main players. One thing is really useful is Red Hat code ready containers. Now, what usually happens is, if I'm doing an implementation or a migration for any customer, and it's to do with a migration from an older version to a new. I will build out their environment in Linux and do the migration that way. So don't ever go near their systems until I can prove what they're trying to do away from their systems. With OpenShift, because there is a quite large footprint to it, and if you're going to install and manage it on a cloud provider, there's a cost to that. But code-ready containers allow you to spin up a single node OpenShift cluster on your laptop, and these are free. All you need is a Red Hat developer account, because so if you want to get to understand OpenShift a bit more and you don't want to rely on works environment or whether there be a cost to it, you can absolutely run this code ready container on your laptop, spin it up. It runs on Windows 10 or Mac OS or Linux, and all you need is a Red Hat developers account, which is free. If you sign up to the developers accounts, you can go to this Red Hat code ready containers page, and you can download the binary for the Windows, for Mac OS or Linux, and you need what's called a pull secret. All a pull secret is a piece of text that just tells Red Hat who you are. It's linked to your account. It's just for running. There's no charge to this. It's just to allow the container to start on your machine. So on my, I'll have a look at one. I've got one installed here. If you download the code, I'm running this on Linux under vSphere ESXi, but this is the same process, is the same if you're running it on Windows or Mac. You'll get a binary file, and you unpack the binary file, and inside there you'll have a single CRC file, and you can it's simply 2 commands to set this up. CRC setup, that's all it is, and then CRC start. Now, if you want to get comfortable with OpenShift without breaking anyone's systems and breaking things yourself, because no one learned anything without breaking an install, you can run this up on your laptop. You can destroy it when you want to and restart it. So if I look at another machine, I've got one running. Once this is up and running, this is a code ready container running inside a virtual machine. So if you run it on your laptop, you'll get exactly the same thing. And when we look to the other demos in a moment, it's as fully featured cluster as it is. It's a single node cluster with a couple of caveats to it. It has monitoring and telemetry disabled, and all that means is when you go onto the cluster on a normal OpenShift cluster, anything by a namespace or a pod will be monitored. But because they're trying to keep the size of this down, this image down small, they disable monitoring telemetry. But if you give it some extra RAM and some cores, you can absolutely switch it on, and you've got a fully working OpenShift cluster on your laptop. It runs for 30 days, then you need to destroy it and reload it again. And I'm assuming that's just for license and thing, but it's an absolutely brilliant way of dipping your toe in OpenShift because it's completely fully functional. I'm going to move on to the next bit. So this bit, is there any questions briefly before nothing on the chat that I can see? Okay, this bit is 5 minutes of techie stuff, and then we can go on to some demos. The basis of Kubernetes when you're interacting with Kubernetes is going to be YAML. It's YAML 8 markup language. When you look at a spec for this type of thing on the screen, if you're new to YAML, it can look quite daunting. It certainly was to me when I first started using it. But there is a format and a structure to the way that the YAML files that Kubernetes uses and the IBM Workload Automation files that are used when deploying the servers and the consoles and stuff. There is a structure to how they're built, and there is a way of configuring them that once you start to use it, it's easy enough to understand because they're mostly pre-built for you. One thing I would liken it to is a silent install file. If you've installed a master domain manager in the past, once you write to get your silent install file, you have to fill that in to say, well, what's the master going to be called? What time zones are going to be in? What's the start of day? Those attributes that can be unique to that master, you would fill that into a silent install file and run it. In this case, a YAML file for building out a server is the same, but with OpenShift, it's also going to build out the requirements for the CPU, the storage, those type of things. So it's a declarative, you've seen that mentioned before, a declarative statement. Here's the list of things that I want. I want one master, I want 2 consoles and 4 agents. And for the master, I wanted to have 8 gigabytes. For the consoles, I wanted to have 6 gigabytes each. So you fill in this YAML description, and you can do it in the console or in command line. And Kubernetes on OpenShift will say, you say to OpenShift, here's the specs that I want, go off and build them. And that's the limit that you need to know. So you don't have to, like in the old days, well, my master's going to go on this server over here, and I know it's the host name. My console is going to go on these 2, and work out the planning session there, because OpenShift can cope with, if you give it enough resources, it will deploy anything you want based on the specification that you've told it to. So there's a snippet of it here. If I look at an example that I've got, if I, on the screen, I don't know how easy it is to read the text, but one of the implementations we're going to look at on my cluster in a moment, IWA prod, is a master, a console, and some agents. And I've just built out this spec to say, well, on the console, I wanted to have a maximum 4 CPUs and 8 gig, but I wanted to grasp 2 and 4 gig once it starts. But if it hits 4 or 8 gigabytes, stop. Well, one version of it, one replica of this particular thing. So when you're looking at when I was saying about the silent install before, we go at things like what's the company names, the type of things that's going to show up on Offman or less. You fill in here at the start of day and the time zone. But once I've got that code, then I can deploy a complete network with just this piece of code. I'm doing this with the command line, but when we were talking about, we've seen demonstrations of Ansible before, and various other things where you can pragmatically declare these type of things in Kubernetes jobs. There's no reason why this couldn't be an Ansible job to deploy your servers. For the purpose of the demo, I'm just walking through it manually. The YAML file containing the definition of what your particular cluster is going to be, the cluster that you're interested in. There are elements in, if you're new to Kubernetes, it works on namespaces, and OpenShift refers to it as projects. And a project is a way of grouping together collections of things that you need for your deployment. So if I have a master that I want to deploy, it needs to have things like secrets and storage and users, those type of things, and you can group those together in a namespace or a project, as OpenShift refers to it. And what this piece of YAML there is saying, well, I want to deploy this particular spec into this namespace. So this namespace could be production, could be development. When you're looking to push these images up, there is various products that you can use to create the images that you get with IBM Workload Automation and configure them. Docker used to be the way that you would push them. You would build the images with Docker and push them into OpenShift registry, but it's fallen out of favor because it requires root to use Docker, and it requires a daemon to run. And there's if you see the release notes from OpenShift 4.2 with IWA 9.5, it refers to Builder and Podman. So Builder and Podman are just 2 technologies to use to build up the applications and push them into the registry so they can be deployed without needing root. And it's far more preferred option now when it comes to getting images into OpenShift. So I'll skip past that techie bit. So what does it actually give you? So I've built out in my OpenShift environment in this case is a development environment. So if you think of, I've got dynamic agents that I want to push out into the system, into my enterprise. In OpenShift, you don't have to worry about, if you can spec this as you would, which you would do in the YAML file that we saw before, we can say, right, OpenShift, I need 3 replicas, 3 versions of this agent, and I want them to have 2 gigabytes. And it will go out and increase the stateful set, which is a Kubernetes term, to say, well, I want 3 copies of this in this particular namespace. So if I just flip over to my console, so this is my cluster of OCP 4.3 that's running on my machines. When you build up, you spec out a OCP cluster, you'll have control planes, which you usually have 3 of. This holds the management and every Kubernetes resource type thing that looks after the health of the cluster and the scheduling of pods, various things. The worker nodes are where the actual applications will run. You generally wouldn't run anything on the control plane. So you can have as many worker nodes as you need to, or however much you've provisioned in AWS, Azure, IBM Cloud, those type of things. In my environment, I just got 3. When I was referring to projects before, if I look at AWS prod, this is a completely separate environment that I've spec'd out, just called AWS prod, and inside this there is 4 pods. Each of these one of them is a master domain manager, one of them is a console, and one of them is a dynamic agents, and these work together to be deployed by the operator. If you read the release notes, you create the operator in OCP and then upload your images and push them out. So this is a small environment, but if I want to increase the environment, if I look at let's look at dev. So this dev environment has got 2 agents, 2 consoles, and a master and a backup master. But let's say I want to increase the amount of agents that I've got. So currently there's only, wrong button, don't want to hit that. This the YAML spec that we talked about before. This is a customized version that I'm using, but the way that it breaks down is there is a workload agent section, there's a console section, and there's a server section, which is the master. And each of these says, well, I want 5 gig, I want one replica version of me. If I go into, let's say, for example, the agent section, and I bump that up to 3, I hit save, I've just told OpenShift, I want 3 replicas of this particular agent, and I want you to go off and install them. In the meantime, you'll see this pod running and starting on this box. Let's give it a minute. And this agent is being provisioned automatically. So if you think of if you have work that you need to create, or you've got a new environment coming along, so you want a new test environment, well, usually you'd have to build a master, a console, and agents on some servers. You have to acquire the servers, install the operating system. With this, I can spin these 2 additional agents up, and they're up in seconds because I've told it what it needs, and it will go off and provision them, and each of those will become effectively live. So in this prod environment, there's 1 master. If I click on this master here, and I go to, let me just go back to my slide a second. What we've just done with 1 click is increase the number of workload agents that are dedicated to a master. Once this scales up, because they're dynamic, it will talk directly to the broker that's assigned to that particular master. And because in the default setting, when I've deployed this master out, is en add workstation equals yes, which is not man set, and those agents that we just applied will be live immediately, and they'll be available to be scheduled immediately. So you can see the demo there that we went from 0 to 3, and there's now 3 agents talking to this particular master. Let's see if we can do this. So I'll go back to my master, checking, no, actually not. In the interest of time, I'll just skip back this and maybe come back to it because I've got a few more slides to get to. But what I was shooting at there was you can easily deploy agents just by increasing the replica count. If you have a situation where you've got an on-premise master domain manager and you've got this OpenShift resources, well, I can spin out a load of different dynamic agents. I can put them in their own namespace, and I can push them out so they join a master domain manager that's on-premise. And you can set things like pools in the spec and OpenShift, and they will automatically join the pools that's on the master domain manager on premise and begin scheduling immediately. So you can scale up as much as you like without having to go out and deploy operating systems. If you need to increase your capacity on the masters, wherever they are, if it's on cloud or it's on premise, to provision agents and increasing your amount of resource you've got is extremely easy. The dynamic workload console is the same deal. So if we're running in a cluster, we don't want more than, we want to have high availability and load balancing. To scale up a dynamic workload console, it's just as simple as changing what I did before, was to change the replica sets. So if I want an environment that has 3 dynamic workload consoles, just scale up the replica set and it will go off and build them. And the way that the load balancing works is a route, which is a OpenShift term, and it allows load balancing internally, so that even if we lose a cluster, or we lose a dynamic workload console run inside OpenShift, you'll continue to route through to the different environments. The master domain manager, if the days of when you provisioned a master domain manager, then a backup master domain manager, and plan them all out, it's extremely easy in OpenShift because it's set to work as a stateful set. So the master domain manager is deployed first. If I want to deploy 3 backup master domain managers, all I have to do is change the replica count, and they'll go off and be built like we saw with the agents before. And they'll immediately become backup master domain managers. They'll log themselves into the database and be ready for scheduling once finals run or GenX plans run. So you can scale up your environment really quickly. And because you're splitting things by project, by namespace, if you wanted to scale out 8 separate master domain managers with their respective backup masters, you could easily do that in the space of an afternoon, without the olden days of provisioning the server, installing the software, installing TWS. Because these are containers, and because OpenShift will do the orchestration for you, you can scale as quickly as you want to. Scheduling is a Kubernetes term. Unfortunately, it clashes with what we know as scheduling, but a scheduler in Kubernetes terms is where are these pods going to move to. So if I've just provisioned in my environment, I've got 3 compute nodes, and I've got 2 separate projects here. This top project, IWA dev, has got 2 agents, 2 consoles, and a master, and this production one has only got a master, a console, and an agent. But because the design Kubernetes and OpenShift designs resilience and high availability, it will position those pods across the nodes. Now I've only got 3, but in a real world environment, you could have 20 to 50, whatever amount of worker nodes that you've got out there. And depending on the amount of resources that your project is requiring, it will distribute those nodes across them for load balancing. And also, if a node goes down, for example, then the pods will be evacuated to another node seamlessly in the background. So there's no manual failover needed. OpenShift and the operator will also always keep an eye on your application to make sure TWS is up, the consoles are up, and the agents are up. But you can build things in like anti-affinity rules. So a smart thing to do, well, if I have a master and 3 backup master domain managers, I don't want them housed on the same physical node, because if the node goes over, then I'm going to lose redundancy. And you can use affinity rules to dictate, well, the master needs to be on one node and the backup masters on separate nodes. Now, this type of organization, when it comes to a rollout on traditional IBM workload automation, takes a lot of planning. So the last one of the recent customers I work with, they had one of the biggest sites that I've worked on, certainly, with 12 masters and 36 backup masters. There was 12 separate environments of a master and 3 backup masters times 12. So in the old way, you'd have 36 different or 48 different operating systems to deal with, 48 installs of TWS or the console, and each of those would have to be planned meticulously. So there's VLANs, there's no overlap, and it takes a lot of planning, a lot of time. But with OpenShift and the correct amount of planning, you could build that out in 2 hours if you had it properly, if you want to do it properly. Simply because all you'd be changing is all you want to do is segregate these environments by namespace, and you've got your YAML file that dictates how you want things built, and they will be identical because the container image that you've downloaded is going to be identical. There is no operating system patches that can knock things out, and there's no libraries that need to be added. So you could stand up that complete environment in the space of an afternoon, as opposed to what generally will take months to roll out, through to provisioning servers, getting an operating system team involved, getting the patching team involved. And that's where the scale and the power of OpenShift and Kubernetes really comes. Right, running on time. If, for example, I've rolled out this based on a namespace, and this one, I can't look at this as IWA prod again. If you have a team that says I want a master and I want some backup masters and I want consoles, and they work in a different business area, well, you roll out these infrastructure to their own namespace, and you can monitor them and you can charge back and you can track their utilization based on their namespace, because only those users will be using it. And these dashboards and monitoring things are out of the box with OpenShift, and it's very powerful in that you can drill down on the namespace at the pod level. You can see exactly how much CPU they're using and when they're using the CPU. So if you're seeing spikes in the CPU usage, you know, when final runs, or if it's when not final runs, that'd be more worrying. Is you can dictate, well, is that, do we need more resources for that cluster? Now, if you're doing without OpenShift, you'd have to have a monitoring package installed on your masters. You'd have to have access and the skills, the knowledge to understand what that monitoring is telling you. If you deploy with OpenShift, it is extremely easy and quick to get that relevant information out to you and to track it without involving a monitoring team or anything like that, so you can see what's out there. I'm going to wrap up because time's moving on, but this use cases, this is 3 things. These are based on conversations that I've had with customers at the last Tivoli User Group and with friends in the industry, and what I would make the case for OpenShift for. So a question at the last Tivoli User Group was, what can containers give me that I don't have already? So I'm a traditional workload automation person. I've got a master and I've got consoles installed. I know where I am, and that's fine. But moving through to the forward, if your workload is going to be more container based and it's going to be more based on the cloud, then you want your scheduling infrastructure to match that, to be able to deal with the fact, well, if I'm trying to talk to a pod that's in AWS, that pod is never going to, may not have the same IP address or host name forever. It's going to be behind the server. So I need to have that knowledge and have my scheduling environment to be able to talk to those different environments, as well as have things like load balance and high availability. What we discussed there a minute ago, of if I had the time, I could knock over a console and watch the route back to different consoles, so that the high availability and load balance is built into the product. You don't have to dictate that or manage things manually. The normal things that you would normally do when it comes to TLS management is all taken care of by OpenShift. If you want to go hands-on to the console, you can, but to do with the infrastructure itself, OpenShift will take care of it. Another one is another customer, a friend of mine, is trying to upgrade to 9.5, but the infrastructure, the servers, the LPARs that were delivered to them, there was missing libraries on one, and they wanted to have a uniformity across their new estate whereby these things are going to be identical. But it's extremely difficult when you're working with an enterprise customer, or you're using a managed service, to prove that the servers that I'm going to be deploying an application to are identical and will stay identical, because the whims of Active Directory pushes, patching systems that are just out of your control and visibility. If you move to containers, you can absolutely guarantee that the code you're running on those servers, whether it's locally or on the cloud, will work the same, and you can exponentially raise that. If I want to create 60 environments, they're all going to behave exactly the same as the first environment that we did. And the last bit, our IWA estate is huge. The time we've upgraded our masters and backups, we're 2 versions behind. And I've seen that umpteen times because of the complexity of acquiring hardware and software and patching, that by the time you've finally upgraded everything, it's time to start over again. It's the painting of the 4th bridge. With OpenShift, if a new version of IWS comes out with a new container, you can push that container image up to OpenShift and do phased deployment. So it's not a one-click all. You can introduce the upgrades on a stage basis to prove you're happy and gently roll them out. But it's still the efficiencies of rolling them out. You could do them all in a single day if you wanted to, or you could stage it over weeks. But the effort of doing the patch is gone away, because you're just pushing out a new container image. You're not running a setup.exe, you're not running any sort of scripting like that. You're just pushing a new image out, which you can test yourselves. And that is it. I've gone a little bit over, I think. Now, there's a lot of demos I wanted to do there, but I've just run out of time, unfortunately. Is there any questions on this?
No, you're still within time. You've still got.
Oh, okay. Right.
9 minutes.
I'm just trying to look at the text.
Yeah, 10 minutes.
Okay, well, I've got 10 minutes. Right. If I look on, let's go to. Just bear with me, I just want to move this thing out of the way. So I'm just going to use the command. I don't know if you can read that very well on the screen, but I'm just going to need to go to the command line for this. So everything you can do in the console, you can do by the command line, which is fine if you're more comfortable with either. The access to the console or the command line is all linked to RBAC, so role-based access control. You would link your OpenShift to Active Directory or whichever authentication method that you would normally use. And the namespaces and all the elements that you would do in Kubernetes are linked to roles and groups the same way as it would do where you're using an Active Directory solution linked to WebSphere roles. And you can decide, well, I can completely segregate one namespace for one set of users, another namespace for another, so they cannot influence those objects, those masters and agents in those namespaces, because they won't get access to them. If you just plan out who wants to work on a particular namespace and segregate the user access to them. So if I look on this one, at the moment we've got a console. This is IWA dev. I'm going to just bring up a console. So this is a dynamic workload console that's running in OpenShift on my cluster. Because there's 2 copies of this, I mean, there could be 8 copies of this, OpenShift will automatically route the connections to the console to either of the ones that are there. So if you have 5 consoles there, it'd be round robin. So usually you would have to have a load balancer in front of a console. There's also performance issues, things like that. OpenShift will do it for you out of the box. Now, in this environment, in this particular namespace, there's 2 consoles. If I just delete a console, like there's 2 running as an example. This is console 1 and console 0. There's 2 of those running. If I just delete one of them, let's do the first one, for example. And that, well, that comes away. I'm just going to keep refreshing that. So OpenShift will realize that that console is gone, and it'll take it out of the pool of being load balancer connections. And because, if I just do OC get all now, because this is a declarative way that we've asked OpenShift to look after this environment, if a console is deleted or its pod is lost, it will say, hang on, you've told me you want 2 consoles and you want 2 servers and 2 agents. If this one's missing, I'm going to go and build it again for you. But in the meantime, I'm going to redirect all the traffic to the working one. So if you have 5 consoles and you lose one, it's no problem, because the users will be redirected to the other 4, and it will rebuild it automatically in the background. So this is the self-healing capabilities. If you define how you want it to look, it will always maintain that environment to how you want it. So if you've got a heavily used environment with 4 masters, 8 backup masters, and one of those goes down, it will rebuild it for you in the background while maintaining connections to the others. So there's no loss of service and yeah. And that will go off. Let's see how long it takes. Well, it's building up at the moment. So if I can show you in the console, but it's quicker to do the status of this console as it being. So this is Kubernetes and OpenShift in the background saying, well, hang on a minute, we've realized this console's gone. You want me to build you one up. So I'm going to go away, pull the image and rebuild it again for you. And as it's being built, you can look at the logs for this. As they're running. So this is the pod being rebuilt from the image of the server coming back up again. So it's done this automatically in the background. It's building it to the customization that included in the YAML files, and it will start configuring it exactly as you want. So if there's connections to the database, it will do all that for you in the background. Now, you don't have to do anything here. If a server goes down or a pod goes down, it's completely hands-off if you want to be. Now, obviously, you can alert against this. You think, well, if a node's fallen over or a pod's crashed, I want to know about it. But if you don't, it will carry on making sure that what you've defined is always up in the background, completely hands-off, which is massive compared to the old way of working, where if a master went down, you do a failover manually prior to 9.5. And if a console went down, you'd have users complaining that it's not accessible. And plus, you have to do things like troubleshooting. Well, why has it gone over? What's different about this box? Why is this box crashing and the other 47 aren't? Well, it could be that someone's installed something on that operating system that's causing it to crash if they've misconfigured something. If you're using this workload console container and it's identical, it will work identically the same. And if you give it enough resources, it will guarantee to work the same in your environment. Okay, anything else I can discuss? I'm just going to cancel that off. Let's see if it's come back up yet. Okay, so that console now rebuilt itself in the background. And as far as user concerned, nothing's happened because they're being routed through to this particular console here that's being load balanced across them all. So you can still see there. If I log on to, actually, let's look at this. The dashboards, etc., all work the same. This is just a master that I've built out with in one environment, talk to the mother. And you've seen 9.5 Fixpack 2. The console is much faster and responsive in my eyes. And when we're looking at the Ansible things today, I've only been sort of dipping my toe in the Ansible water a couple of months ago because there's always something new that comes around the corner. It's something you say to yourself, oh, here's something else I know nothing about. But Ansible, there's a lot of talk about the power of it, and I can absolutely see that. And seeing the workflow in the dynamic console before, where the playbook was deployed and watching it play out, I thought that's excellent. It's going to be really useful because when I've been doing Ansible playbooks, I'm sitting tailing a log file or scouting through a log file, but to see things visually and have that recorded, that's going to be massive. But another plus point, another cheer for Ansible is if everybody probably knows how to do a shell script. I can run a command. I know a bit about Linux scripting, but to get into heavy duty Linux scripting with Python and things like that, it's not a road I want to go down. But with Ansible, a lot of that is taken away from you, because if it's something you're trying to do, whether it's FTP in a file or install an application like Apache that we saw before, someone's written a module for that. All you need to do is understand how to build a playbook, which is extremely easy compared to learning Python or going heavy duty shell scripting, because someone's done it before and there'll be probably a module for it. So all you've got to do is piece them together. And I really like the automation piece in here, because I'm looking at things that I want to implement and roll out, and instead of writing along just winded code or doing an installation, I'm going to go Ansible first, because it's so much easier and repeatable. And I can use it in different environments between test and prod and things. But yeah, an absolute really pleased with that implementation. Right, I feel like I haven't stopped talking for 40 minutes, so I think my throat's going. Is there any question that I didn't really see the chat there? Did anything come out there? I've seen Franco answer.
There was one question from Nigel, but I think Frank answered it. Does anybody else have?
If you want to share with everyone, so the agents was automatically registered on the master, and that's both for on-premise or Kubernetes OpenShift master, and that's driven by enable add workstation. So with that flag, the workstations, the new agents will automatically register as workstations and will come immediately in the plan. And if you're using the pool variable, they will be automatically join a pool, and so if you have jobs scheduled for that pool, that agent right after being started will start getting new jobs from the pool.
Yeah.
The other question.
Oh, sorry, go on. I was just going to show quickly if I just change project to the IWA dev. I don't know if you can see this too well on the screen, but it'd be quicker to do it by command line. When I was talking before, we provisioned out some agents and things like that into IWA dev, and they automatically join the broker. Now, if I want to run something against them, because the add workstation is enabled, what Franco's just been saying there, it's immediately available. And if it's in a pool, it's immediately available. So I can go into, just going to exec into the actual master domain manager on this environment. Now you can do this from the OpenShift GUI as well if you don't want to use command line. What I wanted to get across was, even though this is running in OpenShift or any sort of cloud provider, the way that you interact with TWS, the commands are still the same. You know, all the favorite command SC commands and things are still there. It's just that they happen to be running in a container. So the way that you get onto them, if you're using a command line, you can exec into them that way. If you're using the console, let me go back to here. If I pick on projects, if I look on this one, if I go to IWA dev.
Basically, instead of using a SSH, you're using a OC command line or the UI.
That's it. Yeah. If I flip over to here.
The good is that you don't know where the master is actually running, but you're able to connect to that.
Yeah, and that's it. And you don't need to know, and because the idea of these pods being out there, they don't have a fixed IP address. They can be ephemeral in that they could be deleted and brought up somewhere else, and the same applies here. But you know, there is ways to track where they are. But if you're looking to scale out your environment, you don't need to know. As long as you've got access with the correct RBAC access, you dictate which master you want to speak to, and you know, and away you go. But it still works exactly the same. So if I look at command SC, one of the ones that I provisioned before, yeah. So this is the agent that I provisioned just a minute ago. It's come in with a limit of 100. It's been added directly to the plan because it's been enabled, and you can run a command on it straight away. Okay, and this was the agent I provisioned just a second ago. You know, seconds after it came online, you could run jobs against it. And if they join pool, so that's ran to completion then, and that's something that I've just provisioned a minute ago, you know, seconds ago. And if you join them in a pool, then you can have 5 agents that are all ready to be processed and work immediately. And when you look at things, well, if you have an on-prem estate that you know, you're running out of capacity for, or you want to keep it as it is, well, there's no reason why you can't have dynamic agents running an OpenShift that being pushed into the on-prem master. So in this example that we've got here, my on-prem master domain manager has got 2 pools of agents that are from OCP. One's from a different namespace, but they're working under my master domain manager. So you can increase your workload considerably, because this agent is just a container. It's not a container sitting on an operating system, sitting on a server. It's just a container. So you could have hundreds of these things in comparison to one single server install. Okay, I mean, I think I've got through everything I wanted to. There's more of the demonstration I wanted to get through, but as I said, this is the first time running through. I wanted to have done this at ASAP University before doing it at the TUG, but here we are. Thank you, pandemic. If my contact details on the screen, if anyone wants to drop me a mail about this or any questions, just please let me have them. Thank you.
That's great. Thanks very much, Mark. Does anyone have any questions about anything that we've covered today, or anything in general that they'd like to bring up? If you do, then please unmute yourself and let us know what it is. Can't see anyone unmuting, so I guess everyone's happy. Okay, so it just remains for me to thank all the presenters today. I know it's a lot of effort to actually put everything together for the user group, and we really do appreciate it. 2 housekeeping things. Firstly, ASAP University, as Mark was saying, it was changed to the end of August, but a decision will be made next week as to whether it's going ahead or not, or whether it will be changed to a virtual event. So once we have news, we'll send that out to everyone. The next TUG event, which hopefully will be at IBM South Bank again, but it may well be online if we're still in lockdown, is the 12th of November, so please keep that date in your diary. Maybe what we'll do is a combination of the 2, face-to-face and also online as well, and then more people can attend. Thank you all for attending. hope it's been of value for you, and thank you all for your time today. That's it from me. Enjoy the rest of your day. If you have any questions, then let me know either online or via email. Thanks very much.